Hi guys. Today I am going to take 5-10 minutes to discuss some basics of objects and how pointers to objects work. Because in the last session, I think some of you were not very clear about how it goes, right? And going forward, it will be difficult if it is not completely clear. Okay. Yes, protected is relevant only in the case of inheritance. So if you are using the protected keyword, then it can be the attributes can be accessed from only the inherited classes, not from any outside class. Okay, so is my screen visible now? Okay, there's still some problem, I guess. Guys, I'm going to rejoin in a moment. I think there's some problem with my system again. Please wait. Okay, guys, I think it's visible now, right?
Yes.
Okay, so let's start. So I am going to dry run through what happens actually when you use some common commands that are there very commonly used with linked lists, right? So let us assume that there's something called memory in the system. Okay, let me check the audio. Okay, how about now? How's the audio now? All right. Okay, so what I was saying is that in our computer, there's something called memory, right? And this memory is very big. It contains a lot of space. And in this memory, objects that we create in the Java programming language are stored, all right? And so let's see what happens. So in order to create a node, we write this, right? New node. And let's go by the definition that in order to the constructor to a node class takes in a parameter, which is the value that will be stored in the node. So let's say we do this, we write new node 10. So what our system does is after we write this in the memory, it selects some suitable location, like it can be anything as it suits to the computer. It selects some suitable location and it creates a new object in there in the memory of type node, right? Of using the definition that we provided to the Java programming language, right? We write the class node first before using this statement, right? So uh, on a suitable memory location, the system will create an object, and in there it will store this. The value attribute of this newly created object will be set to 10, and as it is there in our constructor definition, the next will be null initially, right? And every object created in the memory has some address, right? So the address can be anything. Let's say it is ABCD123 for this. And what happens is whenever we write this thing, whenever we instruct the computer to make a new node object, the computer returns the address of the newly created object as well. So whenever we write this, we also need to store the given address that the computer returns. So I wrote this. I instructed the computer to create a new node object, and the computer will return me the address at which it created this new object, and I will store it. I have to store this address variable, this address value in some variable. So let's say I store it in a variable called head, right? So what now happens is this head is now storing this thing, the address of this object. So it will be ABCD123. This address variable is actually storing the address at which this object was created. Okay, so is it clear what head is storing? It is not actually the object, it is the address to the object. Is it clear to everyone? Okay, so this head is storing uh, address to this newly created object. And why do we write node head here? So what this means is head is a variable storing address of a node object, of a node object. And whatever we want to do with this object, if we want to fetch some value from the attributes, if we want to know its value, if we want to see its next address, then we are going to do that using the address that we have stored in the head. Okay, so that is what so far. Yes, head just stores the address of the object, and that address can be used to fetch the actual object which is there in the memory. Yes, we will see that as well. Okay, so now let's see what happens when we want to create a linked list. So linked list does not have a single node, right? linked list has many nodes. So let's say I want to create another node. So this time I am going to store the new node's address in a variable called t, right? And then let's pass it a value of 5. So what now happens is the system will again get some suitable memory location and create a new object. And in here, it will set the value as 5 and next will again be null. And let's say the address of this object was, let's say DEF 567. This is the address. So let's see what we had till now. So head, we have one variable head, which is storing ABC123, right? And we now also have another variable T, which is storing DEF567, right? So this is what we have so far. And now let's see what happens when we make our head variable point to this newly created variable. So how we do that? So in order to do that, we do this, right? Head dot next equals t. So what now happens is the computer will see this head and then it will go here. It will see that head is an address to an object in the memory. Okay, so it has fetched this object and then it sees what I want from the object. I want its next attribute. And then it will see, okay, this object has a next attribute. And then what it sees, I want to set this next attribute now to t. And then it will see what is t. T is this DEF567. So what will now happen is the next of this object will be changed to this thing, DEF567. Okay. So this is what is happening when we create a linked list. This is how it goes in the memory. And whatever we use here, we use T and head. They are only the addresses to these objects. And how do we represent this? We represent this like this, right? So this head node is pointing to this node, which has a value of 5, and 5 is pointing to null, right? And this is how we represent it theoretically. And this is how it goes in the memory. And head we write here because head is actually storing the address of this node. And because T is storing address of this node, we can write T here. So this is how the representation goes. So is it clear till now? Is it clear, guys? Do ask if you have any doubts in whatever I explained just now, because otherwise it will be very difficult going forward. Okay, so also head dot next is equal to, okay. So what happens when I write this is, so the computer sees this head and it will see that head is an address of some object, which is the address is ABC123, right? The address is ABC123. Then the computer will go to the memory at this particular address ABC123 and it will see, yes, there is an object of type node at this address. And then it will see what I am asking next. So I am asking to access the next attribute of this particular object. So then it will see, yes, it had a next attribute. And initially it was pointing to null. It will see that, yes, this object that you are inquiring about has a next attribute, which is right now null. And then what I'm saying is, I want to change this attribute to T. And then it will go here and it will see what is T. So T is address of another variable, another object in the memory. And then it will say, yes, I can change it. So now this attribute will be changed to DEF567. Okay, and the next attribute is storing the address of this object now. Okay, and theoretically we represent it like this. So 10 is a node whose next attribute is storing the address of this object, and 5 is an object. 5 is a node object whose next attribute is storing null. Yes, node is an object, and head is the address of that object. And yes, Rohan, we can change it also. So if you want to change it, let's say I do this, head equals t. So what now will happen is head, the address which was stored in this head variable will now be changed to DEF567. So this is now changed to DEF567 and we can represent it like this. So head is also pointing to this node only. Yes, you can put any name you as you want, Saurav. Is it inbuilt? No, node is not an inbuilt variable. We have to use its class definition first before writing all this code. We need to let the Java language know what exactly is a node. And we do that by writing a new class, right? Okay, so till now everything was clear, right? How pointers work, how objects are. Can we move on to the questions now? Okay, so let's see the first question. All right, so in this problem, we are given two linked lists, right? And by now, you guys all understand what I am doing when I draw this, what all this represents. So let's say we are given this. And there are two pointers that we have, which are A, which is pointing to the head of this linked list, and B is pointing to the head of this linked list. And what we want to know is if the given two linked lists are equal or not. Equal means that all of their corresponding values should be the same. So this is not an equal linked list, right? These two are not equal, but this is equal. These two linked lists will be equal. Right, and we are given the address to the head of both of these linked lists, and we want to check if they are equal or not. Okay, we are given address to the heads. So let's see what we can do. So what I'm going to do is I am going to declare two more pointers so that I do not lose access to these, right? So let's say I create another variable I and j. So I holds the same address as A and j holds the same address as B initially. So this is what I'm going to do. I is equal to A and j is B initially. And then what we want to do is we want to compare each value that is there in the node by the other. So we want to check what is the value stored at I and what is the value stored at j. And if they are equal, the value stored at I and j, then we move forward and check for the next nodes, right? And if at any point we see a dissimilarity, then right away we return that these two lists are not equal. Okay, so how can we do that using loops? Let's see. So let me write this. So while I is not null and j is also not null, right? So we have two addresses I and j which are pointing to two linked lists. So I am going to now check if the values at these two nodes are the same or not. So if the values are not same, if they are not same, then I can straight away return 0. I don't need to check further, right? I can straight away return 0. Otherwise, what I'm going to do is I am going to move on to the next nodes. And how am I going to do that? I is I dot next. I am going to assign it the address of the next node. And the same thing for j. J will be assigned the address of the next node. Okay. And I keep doing this while none of them are null. And if any of I and j become null, then I am going to stop immediately. Okay. So till now, I have written this while loop. Can someone tell me what will I do after this while loop executes? After this has successfully executed, what should I check for? What should I return? Can someone tell me? After this while loop has executed? Saurav, are you sure? Yes, Jay, you are correct. If both are null, then only we need to return one. And in the case that one is null and one is not null, then I will have to return zero. So let me write it down. So if both A and B are null, then they are equal and I'll return one. Otherwise, I'll return zero. Now let's see why we need to check if both are null or not. Okay. So let's say we had these two linked lists. And I is here initially, j is here. So we see that these two values are the same. So we will just move forward. And again, we see that these two values are the same. And then again, we will move forward. Okay, this was I. And then again, we will move forward. And now I is pointing to null and j is not null. So what will happen? We are continuing the while loop only till both are not null. So as soon as I becomes null, we will break out of the for loop, right? And then sort of like you said, if I return one right away, then these two will be the same, right? Going by that logic, these two will be returned as one, while we can see that these are not the same. So in order to check for that, I need to make sure that both A and B are null, and then only I'll return one. Because in a case like this, J will be not null, I is null. And because these are not equal, I'll be returning zero. Okay, so is this problem clear? Is this clear to everyone? Okay, so now let's see the code. It is very easy, I guess. Okay, so this is the node definition, right? And you guys need to write it every time you want to deal with linked lists. Okay, so let me minimize it. And this is our comparing function. So to this function, I'll pass the addresses to head pointers of two linked lists, the head of A linked list and head of B linked list. And then I am going to declare two pointers I and J. Initially, they are same as A and B. And while I is not null and J is not null, I'll do this in the loop. And if both are null at the end, then I return one. Otherwise, I'll return zero. Okay, so this was it. So one another thing, we can also do this problem recursively. So let me do it. Let me explain it. So it's all right if it is not clear what the recursive function does. So let's say again we have the pointers to the head, right? A and B of two separate linked lists. And I want a function which tells me if these two are the same or not. So this function takes head pointers of two linked lists and tell me if they are the same or not, right? And then the base cases we can see from the iterative code that we wrote, right? So if both the pointers are null, then I can return one, right? Because that means that both the input linked lists are empty. And in that case, I can easily return one. So if A is null and also B is null, then I can return one because the input linked lists are the same. And another case is if one of them is null, if only one is null. If this is the case, then we straight away return 0 because one is empty, one is non-empty. They cannot be equal. Otherwise, what we do, otherwise we look at the head value. What is the value stored at head of A and head of B? So if the head values are not the same, then I will return 0 because the linked lists are not equal, right? And if the head values are the same, then I am going to solve this problem recursively using the same function. And what I'll do is this time to the function, I'll pass address of the next node of both A and B. So what is happening here is initially the function had these parameters, right? A and B. The address of this node and this node was passed down. And what I'll do is, so if these two values come out to be the same, I am going to check further. And in order to do that, I'll pass the address of the next two nodes. So the address of this and this. So this is the same type of problem, right? We want to know if these two linked lists are the same or not. 2, 3 and 2, 4. We need to know if they are the same or not. And if they are the same, then we will be returning the answer to this sub problem, comparing of these two linked lists here, and that would be what is returned, the final answer. Okay, so was the recursive code clear? The recursive approach? Okay, so the code is very simple, like even smaller than, okay. So Tejas, the initial problem was of comparing two linked lists, right? And we were given the address to their head pointers, A and B is the address of their head pointers, right? This was the initial problem. And the problem that we are left with after we have seen the values of the head nodes respectively, the problem we are left with is to compare this part, right? We know that these are the same. Now we just want to know if this part are the same for the two linked lists or not. And in order to do that, what I can do is I have the address to this node, right? I have the address to this node and this node as well. So can I not treat it as the same type of problem of comparing two linked lists? This is also a linked list, right? If I have the address of this node and this node, then I can treat it as a same type of problem. What problem? Of comparing two linked lists, right? So this time I am going to pass the address of the next variable, the next node, right? I am going to change the address which I am passing to my function. Is it clear, Tejas? Okay, and the code is pretty simple. It is even smaller than the iterative one. So if both are empty, then they are the same. If one of them is empty only, then they are not same. And in the other case, we compare the head values. And if the head values are not same, then return 0. And if the head values are the same, then we compare the remaining linked list. And how do we get the remaining linked list? By using the address of the next nodes. All right, so let's look at the next problem. So this one, let's say print in reverse. So for printing a linked list in reverse, what I am going to do is I am just going to reverse the given linked list, right? And then I can iterate through the reversed linked list and print it, and I'll get the reverse of the given linked list, right? So let's say this is what we are given, a linked list, and the input given to us is the address of the head variable. Let's say we have the address of this node. we are given the address of this node and we want to reverse the linked list which is headed by this address. We want to reverse it. So my output should look something like this. The final linked list should look something like this, right? This is how the final linked list should look like. And because I need to return the pointer of the head variable of the new linked list, I will return the address to this node, right? This will be my new head. Okay, so is it clear why I want to return the head of this node? Why I want to return the address of this node as the new head? So is the problem statement clear and what I want to do? Is it clear? I want my final linked list to look like this. I want to modify the links somehow in order to obtain this thing. This is what I'm given with, and this is what I want. Okay, so let's see how we can do this. Okay, Vivek, we'll discuss that also. Okay, so in order to reverse all the links, what I'm going to do is I will need two pointers, I and j. And one thing that we need to keep in mind is that I will always be one step ahead of j. J will be pointing to the node that is just behind of I. So what will it look like initially? So initially, I will be pointing at the head, right? And what is behind the head? There is nothing, right? So nothing is null. So j will be initially pointing at null. So let me write it down. So I is initially head and j is behind head. So it is null. There is nothing behind head. Okay. And then what I'm going to do, while I is not null, I need to do something, right, in order to reverse the links. And what I'm going to do is, let's say, let me take another variable. Let me call it t. And in t, I will store the address of the next variable of I, the next node to I. I am going to store this. So what will happen now? I am defining a new variable t, and it will store the address of the next node to I. So this is the next node to I right now. So t will be storing its address. And then what I'm going to do? So like we saw in the result that we want. So head should, so I should be pointing to null, right? But right now it is pointing to this node. So I need to change that, right? So in order to do that, what I'll do is I will now point to j. So I dot next should be changed to j because j is always one step behind and we are reversing the links. So initially it was pointing to the next one, but now it should point to the previous one and the previous address is stored in j. So I am going to change I dot next to j. So what happens now is I now points to null. Okay, and I have done the reversing for this node, and I need to go forward to the next node, right? And one thing that we maintained is that j is always one step behind of I. So I will now go to this node. So j should come to this node. So let's do that. So j comes forward. So j comes here now, and I also moves forward. I goes to this node, and its address was stored in the variable t, right? So I is now t. Okay, so this is what happens now. So I has come here. Okay, so j is now finally here and I is here. Then we'll repeat the same thing again. We'll declare a new t which points to this thing, and we will change the links. So I dot next was pointing to 3, but now I am going to reverse it. I dot next now points to j, and now I am going to move the pointers forward. So J now comes here and I goes here. And then again the same thing, T points here. And then I am going to change the links. So instead of pointing to T, I now points to J, right? And then I am going to move forward by first moving J, and then I'll move I. And now T will go to I dot next, and I dot next is null. So T is now pointing at null. And now I am going to change I dot next to J. So initially it was pointing to null, but I changed it to J, and J was this 3. And now let's move them forward. So J comes here, and I moves to T, and T was pointing at null. So I has now come to null, and we were to do this process till I is not null. So now we will stop, right? And this is what my linked list is now looking like. So now can someone tell me what should be the return value? Which address should I return? What should I return after I have executed this while loop? Guys, what should I return now? No, guys, I need to return J, right? J is the head of the new linked list. J is the new head of the linked list, right? After reversal. So after I have executed this while loop, I will be returning J. So this was the iterative method to reverse a linked list. Was it clear to everyone? Okay, let's see the code. So this is the iterative code. I am going to initialize I with head and J with null. And while I is not null, I am going to do the reversal process. I explained the reversal process, and that is what is written in this loop. And then at the end, we know that J is the address of the head, the new head. And so I am going to return this. Okay. And Dipesh, I explained how to take linked list from user input yesterday, like in the last session. That was on Saturday. How to take input, how to convert an array from, how to convert an array to a linked list. Okay, so this was the iterative algorithm to reverse a linked list. Now let's see how we can do that recursively. So this was the linked list that we had. All right, and we want to reverse it. So look carefully. So what I'm going to do now is, so let's look at this linked list, right? This part, this is pointing to null. And what I'm saying is, if I somehow reversed this thing, right, then what will I get? If I have a function that reverses a linked list and returns me the head of the new linked list after reversal, which is the head, it returns me. So if I had one such function and I called it on this linked list, then what will I get? So if I call it on this linked list, this is what will happen. So the links will be changed like this. This is how it will look like. And the function always returns the head of the newly created linked list. So this is what will be returned, right? This is what the return value will be. I will be returned the address of this node, right? And let's say I called it on this thing. Then what will happen is this part will be reversed. right? This part will be reversed. And this is pointing to null. Right. So this is what will be returned to me, and I will also have the head of this linked list. So now, in order to reverse the initial linked list that I had, the whole linked list, what I want is I want the one to come after this two, right? To get the reverse of the whole linked list that I had initially. And let's say I somehow obtained this address. Let me call it tail. And you guys know how to obtain the tail pointer of a linked list. We discussed that in the last session, how we can iterate through the linked list in order to obtain its tail. So I was given the head of this linked list, and using that, I obtained the tail pointer as well. Okay, and then what I can do is I want this to be, okay, let me call it head one, right? Because these are the same. Okay, so I have the pointer to this node, and what I want is the head variable that I had initially to be the last node of the final linked list. And in order to do that, because I have the address of this one, I can make it point to this, right? Instead of null, I want tail to point to this thing. And also what I want is this will be the tail of the new linked list. So it should point to null instead of this. So it is now pointing to null, right? And now you can see that I have indeed reversed the linked list. Okay, so let me write down whatever I did. So there's a function which takes the node of the linked list, the head of the linked list that we want to reverse. So what will it do is, so one thing that we can see is if head is null, if the linked list is null, then the reverse of a empty linked list will be the same, right? It will be null only. Then I can simply return the same thing. And also another base case that we can see for this recursive function is that if the linked list contains only one single node, and that means that head dot next will be null. So if this is true, if head dot next is null, then also I can return the same thing. I can just return head, because reverse of a single node is the node itself, right? Otherwise, we are going to do what I demonstrated earlier. So I am going to make a new variable temp, let's call it. And in this, I am going to store the output of the reversal function when called on the later part of the linked list. So I am going to call this same function reversal, or let me change the name to reverse. So I am going to call this function recursively over the next node, head.next. And what this is going to do is it will reverse the rest of the linked list and return me the head of the newly reversed linked list. So now I have the head of the newly reversed linked list, right? And then what I needed was the tail, right? So let me obtain the tail as well. So in order to do that, I am just going to iterate, right? So while t dot next is not null, I'm going to do, okay, this should be tail. So while tail dot next is not null, I am going to move the tail pointer forwards. Right. And then at the end, I will have the tail pointer of the smaller linked list, right? I will have the pointer to this node. this tail I'll obtain after this while loop. And then what I want the tail to point to the initial head that I had. So tail dot next should be head. So now this tail variable points to this head. And also what I want is I want the head to point to null, because now it has become the new tail, right? So it should point to null, and that is what I did. Head now points to null. And then what I will return, I will return the address of this node, which was stored in T, right? And then I'll return T. Okay, so what about this? Is it clear? Is this explanation clear to everyone?
Yes.
All right, so let's see the code. So what is happening is if the linked list is either empty or a singleton, or that it has only one node, then I am going to return head itself, because a reversal of these two cases is the same thing, right? And then I am going to reverse the later part of the linked list, right? And I'm going to store its head into this variable called T, right? And then I'm going to use this current variable to get to the tail of this linked list, right? The linked list pointed to by T. I am going to get to the head, tail of this, and then I am going to make this tail point to the initial head that I had, right? And then the head will point to null because it has become the tail now. And then at the end, we'll return T. So this is how you can reverse it recursively, right? Is it also done take 4 as head, then move backward to 1? Rajat, I did not get what you are saying. Can you unmute and speak up? Or let me just dry run this recursive thing again. Okay, so this is what we had initially. I mean, you take 1 as head, right? Yes, 1 is the head. Okay, let me dry run it again. So this is how we were initially, right? This is the condition that we have. And then what will happen? We go through this function, right? With this initial head, we go through this function and we see, is head null? No, it is not. And then we see, is head dot next null? So no, that is also not true. So we will come here, right? And we will store, we will call the reversal function, the same function over this thing. We will call the reversal function over this thing and store the head of this reversed linked list in T. So what will happen now is, because I called reversal over this part, this is what I'll get. So this is how the later part will now look like. And I will be returned the address of this head, this node, and that I'm storing in T, right? I'm storing that in T. And then what I'm doing, I want to obtain the tail of this linked list, the tail of this thing, right? And you can see how I am doing that, just iterating through the linked list simply, and that is stored in a variable called tail. So after executing that for loop, I have obtained the address of this node as well, right? After we have executed this while loop, this is where we will be at. And then what I'm going to do, I will make this tail point to this initial head. So tail now points to head. Like this is how it will look like, right? Tail now points to head. And then what will happen? I am doing head dot next equals null. So head will now point to null. So head is now pointing to null, right? So if I draw it again, then this is what the condition is now. So 2 is pointing to 1 and 3 is pointing to 2, 4 is pointing to 3. And this is the address of this node. It is stored in T, and this is stored in head, and this is stored in tail. And now I have reversed the whole linked list, right? And then at the end, I am returning T, which is the head of the newly created linked list. Then I'll just return T. So it's same as when we go from right to left in array. No, Tejas, not exactly. Here we are actually modifying some stuff. When we go through an array, we don't really modify anything, right? Here we are modifying the links that were there. Is we taking always first element is head. So same like can we take as last element? Yes, the first element of the linked list is the head always. The first element is going to be the head. Okay, so this was the reversal problem. And now someone was saying how we can print a linked list recursively. Okay, so again, I'm going to take the same example. Right, and we are given the address of this head. And we want to print, we want a function print, which takes the head of a linked list that I want to print out. So the base case that we can see easily is that if head is null, then what I'm going to do, there is nothing in the linked list, so I can simply print a new line. I'll print a new line, right? If it is empty, and then I'll return. Otherwise, what I'm going to do is, so in this linked list, if we want to print this, the head will come first, right? We'll first print the value of the head, right? So I am going to do that. I'll print head dot value, the value that is stored at this thing, right? I will print head dot value, and then, okay, let me change this a bit. So this can be a little confusing. So I am going to be using system dot out dot println, right? And then I am going to be printing this thing again, the value stored at the head using system dot out dot print. I'll print this value, the one that is stored at the head, and then I will call the print function recursively for head dot next, because now I want to print this linked list, right? I have already printed this. I want to print this part now. So I am going to call this function recursively for head dot next. Right, this is what I'm going to do. Okay, so I think this is a very simple function. I think I can dry run this using memories. So let me do a dry run. Okay, so we discussed what addresses are, right? Every object has an address. So I am writing some arbitrary address, right? You can assume that the address of this node is, let's say, A1, and the address of this node is B2, and address of this is C3, and for this, let's say it is D4. So what is happening is, so in the first call that we made, we are passing the address of this head node, right? We are passing the address of head. And what is it actually? It is just equal to A1. So we are actually passing it A1 in the first call. And what will that do? So because A1 is not null, then it will print the value that was there in this node. So it will print 1, right? And then we know that it will make another call, print for head dot next, right? It will make another call, print head dot next. And we see that what is head dot next? Head dot next is address of this object, right? Address of this object. And what is its address? It is B2. Right, it is B2. So actually, we are making a call by passing in this address, B2. And we see that because this is not null, we will print this value as well. So we printed this, and similarly, we made another call. And this time, we will pass the address of this node, which is C3. And again, this is not null, so I'll be printing this thing, right? And then in the same fashion, I'll be passing the address of the next node, which is just D4. So I pass the address of this, and this is also not equal to null. So I'll be printing this value, right? And then I'll call the function once again. And this time I'll be passing this D4.next, which is actually null. So this time I'll be calling it with null. And because it is null, this time I'll print a new line, right? So was this dry run clear? I think it should have explained pretty well how recursion is going to work in case of pointers. Was this dry run clear? All right. So we're going to discuss the remaining problems in the next session.
Guys, we'll start in 2 minutes. On an average, how many people were there in doubt session? 34, 30. Okay, cool. So, good evening, guys. So we were talking about linked list, right? So we talked about why linked list, what's the benefit of linked list from array, and we talked about like we coded up the classes, and we talked about the logic for inserting at beginning, end, and at certain point, any point. Yeah. Yeah, Jay Patel, array list is something like it is inbuilt Java. I mean, it's inbuilt Java in Java collections. There is Java collections, something like that. We will go there in upcoming lectures. So there are like particularly 2-3 lectures on to cover Java collections. So that's like default thing with more options more than a normal array. So we'll see that in upcoming lectures. We'll learn that. Okay, so cool. So I gave an homework, right, for the weekend. Did you guys do it? Do you guys remember what's the homework? Delete, yeah, correct. So did you guys try to write down the logic? How to delete the first element? How to delete the particular element, or how to delete the last element? Did you guys try to write the logic? Everyone? Anyone who got it? Hmm? Hush, did you get it? No. Like, did you get it? Yeah, correct. Head equal to egg dot nest for beginning element. Like, did you guys, anyone, like everyone tried, right? We are going to jump there only now. First traverse, yeah. You know what? Like, we'll jump into that. So before that, does everyone, like we talked about inserting, right? Shall I revise inserting quickly, showing the slides, or shall we directly jump into delete? Do you guys remember how to insert at the beginning, revise? Okay, revise. Okay, everyone are saying revise, so I'll revise it. Cool. So yeah. Perfect. I'll revise then. So let me just quickly open it up, my PowerPoint. Okay. Okay, cool. Yeah, it's okay, Tejas. Like assignments are more prior. Put assignments like give good amount of time to assignments. Okay, cool. Okay, we are on the right track. Let me pin and let me close the video for better view. Okay, perfect. Can you guys see PowerPoint and insertion thing? What was written? Yeah, cool. So for we have 3 insertions thing, we have 3 deletions, right? First of all, in first insertion, it's like insertion at the beginning. What should we do? So we have an head and we have a linked list like this. And for updating it, first of all, we have to create a node using this node class. This class is there, right? Data and next will be there. Using this, we'll create a node and change the next of new node. Whatever node we created here, whatever new node we created here, we have to update the next of new node to the first node. And then we have to update the head to new node. But we should not do in reverse order, right? You saw why, right? Because the moment I update my head to new node, I'll lose whole my linked list. So first of all, order is important here. Like yesterday, some people did that mistake. Is it cool? Order is important. So first of all, change next of node, that is this, change the next of this, which is a new node, and update next to the first element, and then change head from here to new node. So now I inserted the beginning, right? I inserted the element at the beginning. So now my linked list starts from new node, then here, then here, then here, and obviously last one is null. Did you guys understand here? Order is important. So here inserting at end. So obviously first we have to create a new node as usual, and then we have to traverse until the last node. The moment we come to last node, we have to update the last node dot next to new node, and then that's it. We don't need to change head, and we don't need to change anything. Just traverse until the last node and then update it to new node, last node dot next. Okay, this is inserting at the end, and inserting at the specific point, we should come until the previous. See, given previous node matlab, if at all they're giving, well and good. If at all they're not giving and they're just giving the value of it, we have to traverse until the previous node. So node right after we have to attach. Here also order is important. So let me quickly say 1, 3, okay, 4. I have to insert 2 at in between 1 and 3. Okay, so first of all, as usual, create a new node, which is 2. I created, and then this is my previous, guys. This is my previous. Okay, so what should I do? I have to first, before, see, we have two steps. We have to update the link of previous dot next as well as new node dot next. This is new node. Okay, this is previous node. Okay, here we have two steps, right? One is updating previous next to new node, and new node next to previous dot next. But the point is, if at all we are updating previous dot next first to new node, we are losing away we are losing away all of our linked list after previous node. See, the only link which is saving the after previous node ka linked list is this only link, which is previous dot next. So to see, the moment I change it to new node, I lose track of all of it. So that's why first of all, I'm going to put new node ka next to previous dot next, so that even if I change previous dot next to new node, it is being saved. Did you guys get the insert? I quickly explained. Everyone, is insertion clear? If at all it's not clear, please unmute and say your doubt. Yes, yes. Anyone? Anyone? If it's clear, type clear. If it's not clear, please unmute and say. Any doubt, guys? Anyone? Even if you didn't understand, it's fine. I'll repeat again. Same logic, almost equal logic, we'll use it in delete also. Like every time order is important. See, in linked list is not a very difficult thing. How to take user input. We'll do that now. We'll do that. User input using scanner. Those things are, I'm not getting what do you want to do, Divesh. Like you want to take user input and then create a linked list. Like that, Dipesh. Like we'll do it in code later, but yeah. So see, node input, I guess. Node input kya? We'll see, to just create a node, we'll just first we'll create a class, right? After that, we'll just write node and then value. If at all we want value 1, and then it will create node 1. It will create node value 1, and then which is pointing to null. Okay. So guys, in linked list, there will be only few operations, but the order is very important. Always focus on order of the operations. See here, this easy problem, inserting at specific location. I have just 2 operations, but if at all you're doing ultana, your problem will be totally gone. So you have to follow the order. Okay, let's go to delete. So this is the homework which was given: deleting the first node, deleting specific node, given previous node, deleting last node. These are very simple. So first of all, let's talk about deleting first node. Guys, I'm talking about this, and then later on I'll code these 6 functions. So deleting first node. Okay. So let's say, so basically simple, right? If at all 1, 2, 3 is there, okay, and my head is pointing towards 1. Array, what should we do, guys? Put out the code. See, so you guys, like, I just have to delete. Delete matlab not just remove it from our system. That we can't do ever. So now what is the one thing which is saving our whole linked list? Head is the one pointer which is saving our whole linked list, right? Yeah, exactly. So no, Jay Patel, it's opposite, na? Yeah, just move head to next thing. So head equal to head dot next. So what is head dot next? Which is this. So we have to just transfer it there. That's it. Okay. So head equal to head dot next. Is it clear? I want you guys to write down the code for delete from end, changing address of last -1 node, then last node would get deleted. Changing address of last -1 node. Yes, exactly. If at all Tejas is asking, if at all I'm changing the pointer of next pointer of last -1, n -1 node, we will lose our nth node. Correct, Tejas. So I want you guys to write the code for logic for, logic or code, whatever. So delete from end as well as delete if previous is given at specific location. Take 2 minutes and put headings in chat, and then write 2 and then write answer for this, and then write 3. So delete from end, and then delete if previous is given. I'll give 2-3 minutes. Okay. Guys, always the best practice is to take example, something like 1, 2, 3, 4, and then work it out to make last second. Rohit, you should say not make last second equal to null. You should say make last second ka next equal to null. Got it, Rohit? Because that totally changes our answer. If at all you're making last second to null, it will become only 1, 2, but it should become 1, 2, 3, right? So yeah. Nice. Or you can just put logic, guys. Like you can just say traverse previous dot next equal to null. Okay, great. So what's our logic here? So the moment I'm putting it to null, this will get cut away, right? Great. Okay, guys, I'll just say logic here. Everyone, okay? So first of all, logic is traverse to last second element, last but one element, which is 3 here, and then we have to update last second element का next. So last second element का next to what? To what? What should I update it to? Null, exactly. Because the moment I update it to null, I'll be losing my last element, which is what our target is. Now coming to this question, if at all our previous is given, so what should we do? Simple, na? What should we do? If at all our previous is given, so like, no, Sharan, no. See, if at all 1, 2, 3, 4 is there, if at all I want to delete out 3 and 2 is given, if at all 2 is given, this is previous. If at all it's not given also, it's fine. We will traverse until there. So it's if it's previous, what should we do? The moment you're putting previous dot next equal to null, it will become 1, 2 only, but it should become 1, 2, 4. Exactly, Swapnil, correct. Link 2 to 4. How would you do it? How would you link 2 to 4? Exactly, Tushar said the right answer. So what should we do? Previous. Array Akash, why are you putting it to null? Here we don't want to delete whole array. I mean whole linked list. We just want to update previous dot next, which is this previous dot next to previous dot next ka next. So updating it here. The moment you update it here, this is our head, right? So from here, our linked list will be like this. Cool. Got it? Everyone, shall we go to code? Everyone, these three, you got it? See, it will take a lot of time in code. So that's why anyways, I'll explain it there, right? So I'm moving thoda quickly compared to previous. Cool then, perfect, excellent. Can you show how to delete from end? Yeah, Ash. The thing is, first of all, I'll traverse until the last second element, which is 3 here. The moment I come here, what is last second element ka next? Harsh, be active. What will be last second element ka next? Last element. So which is 4. So I don't want that, right? So I'll do last second element ka next as null. So that I'm losing last element. Delete from end means delete last element, I mean. Cool? Yeah, cool. So yeah, guys. So let's go to code. Okay, I'll just keep it. Okay, great. Okay. Okay, great. So we'll, as usual, create a class like yesterday. So class will be linked list. And then here we'll have node head, because like in linked list, we'll have no head, right? So guys, this will be a long code. We'll be just losing the address of node, but it will be okay. Abhishek is saying we will be just losing the address of the node, but it will be still there in the memory somewhere. Yes, it will be somewhere there, but the moment we lose out that, it doesn't matter. It's just garbage to us. Like we can never find it, right? The moment we lose that link, but it'll still be there in memory, but we can never find it. Got it? So that is why, see, but it'll still occupy it. Yeah, it'll still occupy. We can't do anything about it. But it, see, compared to the memory and everything we have, it's literally like ant in an ocean. So we won't worry about losing out some integers or some nodes like that. So we won't consider that as a disadvantage for sure. See, whatever it is, you can't just erase it from your memory. Okay. So it is also same like array. And one more thing, guys, if at all I lose the head pointer of linked list, what will happen? If at all for some reason, I lost the head pointer of linked list. What will happen? Exactly, we'll lose entire list. Exactly, we will lose entire connections, right? We'll lose an entire whole list is gone. Exactly. Srinidhi, why did you put array? What do you mean by array? Yeah, everyone, right. We'll lose entire. Okay. Are you sending anything? Okay, cool then. Let's see in linked list. First thing we have is head. So I'm going to create, so here only, so I'll create a class node here, which will have integer data and node next, right? And then what will we have? We'll have a parameterized constructor node. In that we'll take integer value or something like D. We'll take value from user, and then we will update the data. Data is there, right? Data is equal to value, and then we'll update the next equal to null, just like that. Okay, so this is the class node, this is the linked list class. Is it clear? Okay, great. So now after creating the linked list, we'll add some functions here. So let's go a little bit down like this. Okay, okay, great. Like this, it's nice. Okay, cool. So here we have, first of all, we'll create something like we'll insert at starting, right? So we'll create insert at beginning. So it will be public void. See, I'm not going to put static, okay? Because static we should put for what functions. For what methods we'll put static generally. Main, exactly. Because we want it to run every time. So, but it's a normal function, right? So I'm going to put it as void only normally. So we'll put insert at beginning. Okay. And then we'll take, see, every time will be given, every time will be given with data, which is value. And then see, let's go to our logic and then we'll code it up accordingly. Okay, guys. So insert at beginning. So first of all, we are given with data. Okay. So now what should we do? What's the first step? Create a node. So I should create a node. So node, new node, create a new node, right? I'm creating a new node, which is equal to new node. And what data should I send here? I should send value, right? I should send the value, right? See here, parameterize constructor mein I'm taking value. And then I'm equaling it to data and updating data and next from here. So here I should send new data, right? And then what's our next step? Change next of new node to the first element. See, order is important here. Change next of new node to first element. So new node dot next. First element is what? First element means what, guys? Tell me.
Head dot next.
Why head dot next? Just head, right? Because head is okay. It depends on, like, I'll just show later. Like our after code will depend on this. So what is this? See, head dot next means what? It's second element, na? Whoever said it, got it. If at all you're putting head means it's first element. But if at all you want it to be second element, then next dot next. Got it?
First element, right?
No. Don't consider head as the first element. Okay, wait, let me show. See, 1, 2, 3 linked list hai na? So 1, 2, 3. We have only 3 nodes and one is the first node. To have the link for first node, we will put a pointer. And then we'll put a pointer. Head is not a node. Head is a pointer which points towards the first node.
Yeah, that's what I'm saying. Like head, the pointer should be head. The pointer should be next That is new node to our new node.
Array for nodes, for accessing the next element, we will put node dot next. But for pointer, we won't put dot next. The moment if we are putting wait, let me say, so this is the new node, okay? Let's say this is a new node. The moment I'm putting, see, new node ka next equal to the moment I'm putting head, it will directly attach to the where this head is pointing. Got it? It works like this.
Yes, understood.
Cool. So why are we not writing like ll dot head like yesterday? Array, it's inside a class, na? It's totally inside class, and it's a see, this head is there, right? It is a node. It's outside this, so if any function can access this head directly. So, but when see, last time we created outside, na? So that's why we are putting linked list dot head outside. Got it? Cool. So great. So the first step is done. Now coming to the second step, what is it?
Can you explain line number 17, please?
Line number 17. Okay. See, this next is there, right? This next pointer.
Yes.
This next pointer is actually pointing to a node. So that's why the reference type will be node.
Okay.
Yeah.
So
that
can call class directly inside of a class, inside of its own class, or any other class.
Repeat it.
Like you wrote node, and node is the name of the class. So basically, what you're doing is you're calling the, like you are using the name of the class directly, right?
Yeah.
Okay.
Yeah. Next, see, basically you should understand like this. Next is pointing towards one more node. So that's why this next pointer will be having this node ka data type. But whenever you really want to create a node, this is what you have to do. Here next is not, we are not creating next as a proper node. We are not allocating space and all. If at all you want to do it, you have to do like this. Okay, what is the next step? Update head to new node. How to do it? Head equal to new node. That's it. Is this clear? This function? That's it. This function is, that's it. Yeah, exactly, Abhishek. Good. Yes, everyone. Shall we go to next function? Line 18 is creating new node, right? No. See, line line 18 is a parametrized constructor. It's not creating anything. It's updating the data and next values, next variables to value and null. It's not creating anything. It's updating the existing data variable and next variable to value and null. Got it, Tejas? Okay, cool. Is this function clear? Shall we go to next function? We'll create something like insert at end. Okay. So before even going to middle thing, we'll first create insert at end because it's very straightforward. So public void insert at end. Right. So obviously it will take again same new data. Okay. And then what should we do? Let's go back to our logic. What should we do? Create a new variable. So directly do this. Copy, paste here. Let me go down, Thoda. Yeah. So now what should we do? Traverse until the last node. We have to traverse until the pura last node. And first of all, before even going to see how to traverse, before even traversing, first of all, I need to check, right? See, if at all my linked list is nothing, what should I do? See, always you have to focus on edge cases, right? Okay, I don't know what's going on. Cool. Always you have to focus on edge cases, right? So if at all there is no node at all, what should we do? If at all they're giving us a new data and there is no node. Exactly, Vivek. The thing is, first we have to check if is my current head equal to null. If at all it is, then what should we do? We have to create a new head which is equal to new node, which will point to this new node and new data. And then we will return it. Right? Correct. And then we will just return it. And now we created a new node which is giving to new data. So now what should we do? We will create something. See, now traverse until the last node and update the last node dot next to new node, right? So what should we do? Let's create, see, we have to go until the last node, right? So we'll create something called temporary. Okay, we'll create temporary variable which points to head, right? So now what should we do? Yesterday I said, right, we have to traverse. Good. So while cur, right? Okay, let's use cur only. You guys are comfortable with cur? Cur means current. Current, we are at head. So now we have to move until the last. So how to move? When current dot next is not equal to null, if at all current dot next is not equal to null, then what should I do? I have to move to the last. In last element, what will happen? Current last element dot next will be null, right? Sorry, where is it? Last element dot next will be null, right? So the moment last element hits, it should exit. So what should I do? Cur equal to cur dot next. Array, why is it not typing? Array, wait a minute. I don't know why it's got stuck. Can you guys hear me? Ah, okay, cool. It's not moving. Okay. Come on, man. What's going on? Yeah, I'll just wait for a quickly. Yeah, Eclipse is better. Okay, great. Finally, cool. Cur equal to cur dot next, right? Array Eclipse may again files and all will be there. This will be so easy to show, right? So that's fine. So see, cut dot next, I'm going to last element. So what should I write? Traverse to last element, right? So after traversing to last element, what should I do? Update last node dot next equal to new node. What is now? Now what should I do? What is my last node now? What exactly is my last node right now? Current, right? So what should I do? Cur dot next. Exactly, cur. So exactly, cur dot next is equal to new node. Exactly, perfect, very nice. So what should I do now? Just return. I don't need to return because it's the last, but I'll just return it. So is this function clear? Insert at end.
It is a void function, and if you are using
I'm not
return,
returning anything, bro.
okay.
So if at all I'm not returning anything, it's just void. But I wrote return here because head is already null. I already created the condition. If at all I'm putting cut.next here, I'll get error. So I have to get out of the function right here. But here I don't need to put return. Cool. It's totally upon us.
At line number 37, you return, you wrote return. Otherwise, you would have got error at line number 41.
Exactly. So
in the 36th line, can't we write directly head is equal to new data as new node is already created? So head is equal to new node.
oh right, yeah, we can do it. Yeah. Great, I actually forgot. Cool. And that's it. Right? Shall we go to next function? Is it clear? Is this function? Insert at end. Creating a new node, checking the edge case, traversing to last, updating the last. Right? So now we'll create a insert function, which will take the previous node and then we will update it simultaneously. Like, okay, let me go here. Okay, here given at a specific location, right? And then we have a previous node here. Alright. So we have a previous node here, right? So what should I do? So again, public void insert after at a position after, and then it will take node, which will be previous node. And then what will it take? Integer, again, new data, right? Now, first of all, what should it do? Tell me.
Previous node.
I can't hear you. Yeah, before, yeah, wait a minute. Yeah, everyone are going directly to point, but the thing is, Prashant got the point. The thing is, first we have to check whether our previous node is valid or not. Check whether our previous node is valid or not, right? So first of all, we have to check. So if at all previous node equal to null, then what, like, then we have to, like, it's just error, like it's just so what shall we write? Error previous node is null, not valid, right? And then if at all it is the case, I'll just return, right? So this is the if statement we are going to use, because like if at all the previous node is null, then we can't really see where shall we update if previous node is null. So shall we do one thing? So okay, you know what, like if previous node is null, it's simply not valid. So insert after, right? So what should I do? So again, order is important. New dot not next equal to previous node, and then previous dot not next equal to new node. Again, do the same thing. So we'll take this from here, this line. Okay, I'm creating a new node, and then update the new node next to previous dot next. See, that's what we wrote right here. Previous node next, and then update previous dot next to new node. See guys, if this logic is clear, you won't be having any problem. This logic is clear, right? If previous node is given, how to insert. Cool, everyone, that is it. Shall we go to delete function? Shall we go and code this delete function up? Is these three functions clear? See, if at all these logics are clear na, for you, no problem will be there. See, why I'm okay. I have a question. So, see here at insert at end and insert after, I'm having yeah, I'll share Abdul. Yeah. So how will they give previous node ka input? They'll just give, bro. How are they giving integer ka input? How are they giving array ka integer array ka input? In the same way, they'll give node ka input. Like just
Like we will not have the address of the before elements of the previous node. Right?
array. Don't think. See, why are we creating methods at all? Why are we creating methods at all? The moment I write this method, it doesn't mean it will applicable. It will execute right away. Whenever we call, whenever, see, let's say this kind of example is there, right? Let me take annotation. So 1, 3, 4 is your existing linked list until now. Okay, this is head, always point head to. Okay, so now you will be given with your this whole node. So how does it look? How does it look? It will look like this. Will look like 1, and then the next will be pointing to 3 ka address. Here 3 node ka address will be there, right? So, and your new data will be 2. So what am I doing? First I'm checking is previous null, no, right? And then I'm creating a new node with data 2. And then what am I doing? New node connects to previous node connects. Previous node connects is there here. Okay, and then new node connects is got it up, Vivek? Yeah, cool, great. So Aishwarya means node value. I didn't get your doubt, Aishwarya. Like, is there no doubt or any doubt? Like, I didn't understand. Means node value means. Yeah. No. No, Aishwarya. They are not giving previous node ka value. They're giving previous node itself. In that value is there. Next is also there. Okay. Saurav's question is, for insert after, we need to create a new parameterized constructor with node and value as arguments. Otherwise, error. We need to create a array for methods. Why would we create constructor? For class constructor will be there, right? For insert after, we need to create a new parameterized constructor with node and value as arguments. Otherwise, parameterized constructor. Array, Saurav, I think you can unmute now every time you'll talk. Please, can you unmute and say, I didn't understand. See, for method. Yeah.
Okay, I need to understand this because I got confused here because
Okay. See, this is method. Methods won't have constructors, right? Class will have constructor. And why constructor?
To give the value.
Yeah, to update the values. Array, how to remove it? Wait a minute. Yeah, to update the values of, to update the variables of the class, right? Here node is there. That's what I'm doing, right? Yeah.
Cool.
Yeah, cool, right? Cool. So insert is done. So let's go to delete. Is next a constructor? No. What next is next is a pointer, right? Which points to nodes. Oh, okay, cool. So let's go to our delete function now. So see, we have delete 3 things, right? First, specific and last node. For first node, it's very simple. For last node also, we have to just traverse. And then for specific node also, we have to just traverse until there and then make it next, right? So what we'll do is, we'll just create one function for delete. Okay, we'll just create one function for delete. Public void, simply delete node. This will take position, okay? This will take position. So first of all, what should be my edge case? Always consider the edge cases. See, this is the main, very important in any coding question. This is very important. Always try to find any edge cases are there and first code it up. Because in linked list, especially if you're not coding up edge cases now, you will definitely get error later because we are going to use next and all. So always edge cases will be like, is it null? Is my head null? Like that. So here my edge case is my head null or not? So if at all it's null, I don't have anything to remove, right? So it's literally pointless. So I'll just return it back. So if at all head is not null, I'm going to create something called cur or temporary. Okay, I'll just put temp will be equal to head. See how I did here cur, right? In the same way, I'm doing cur here. We'll just fix with one notation. It's fine. So now what should we do? What should we check? Always divide it into cases and solve separately. What should we do? Anyone? Exactly. When should I delete head, Harsh? When should I delete the head node? I mean, node pointing to head. Jay Patel, right? Increase current till we get to the point, till we get to the position, right? So before even going anywhere, if exactly Swapnil got there. So if at no Swapnil, even if it's having one member, it doesn't matter. Our position matters, right? So if at all my position is like if at all my position is 0, right? So I should remove whatever is there on 0th position. So my head will become what? Cur dot next, right? My new head will become cur dot next, isn't it? And then I'll just return it back. Yes or no? Yes. We have to delete the first if at all position is 0. Now we have to see, we are given with position, right? What position is it? So I'll just go until yeah, first I have to go until the position until there, right? So I'll just go with while, yeah, we can do that. So first let's draw a yeah, Vivek, we can put for loop also. Okay, let's put for loop only. For int, okay, first we'll create variable int and I, and then for I equal to from where? From 0 to I less than position -1. Exactly, Vivek. Position -1. So it will be totally position -2 times. We'll go until the element and then I plus plus. And then what should we do? See, before even going, see, if at all my position given is something like way far than my linked list itself, I have to check one more thing, right? I is less than position. I have to check one more condition right here. My temp should not be, my current should not be equal to null, right? Yes or no? Are we are going until the before element, bro. See, for deleting the node, we have to go to the previous, right? So position means position -1 place mein the node we have to delete will be there. So if at all we are going until the position -2nd place, then we can just do, okay, let me just show curry equal to cur dot next. I'm going and I'm exact, got it, Jay Patel, yeah. So the moment I'm where does cur value starts from? Are curry starts from head na? So the first of the linked list will be going to the exactly previous node. So right now I'm at previous node. Now what should I do? Simply, I'll just, what should I do, guys? I have to just simply create a new node. Cut dot next equal to cut dot next text. Great. So cut dot next equal to cut dot next dot next. Right? Cool. So the moment I'm coming to this position, let us once look into it again. Let's do it with one try run. So 1, 2, 3. Okay. I'm very. Wait a minute. Okay. 1, 2, 3, 4. Okay. What position shall we take? Let's say position 2. Okay. So first of all, we are starting with 0. So this is the head, and here only we are putting cur, right? Okay. So first of all, we are going from I equal to 0 to position is 2, right? Position -1, which is 1. So 0 and 1 until 0. Wait. Position equal to, what should we do? See, if the position is 2, if at all the position is like this, then what would we do? The position itself is 0, then there is no position, then we have to just make the address equal to new, and then 1, 2, and then my I is starting from 0, and then I won't go until 1. So okay, my I will be only equal to 0. So only one time my for loop will run, right? So my cur equal to cut dot next for the first time, right here, right? And position equal to 2. 3 should be removed. So what should I do? Cut dot next should be going to cut dot next next. So this is right. Is this function cool? Everyone? Delete node ka function. This 2 is my index, which is position. Didn't get line 71. Okay. Okay, great, great. Tejas, did you? Okay, you know what? Let's see. Everyone, please focus here. So 1, 2, 3, 4. And obviously, my head will be always pointing to 1, right? So what am I doing here? I'm creating cur variable, which will be pointing to head ka node, right? And now I am going to traverse position minus 1 times from 0, means position minus. So what is the position here? My given position is 2. So Tejas, what element should I remove now? If position is 2, you can put it in chat box. Tejas?
How
Yeah.
position 2 means the node 4.
Are
Or-
position 2 means what, yeah? 0 index, 0, 1, 2.
Yeah. So yeah.
3, right? 3, right? So I have to remove 3. So basically, what should I do if I have to remove 3? I have to update the 2 ka next, 2 ka pointer ka next, 2 ka node ka next to 4, na?
Yeah.
Yeah. So what should I do? I have to somehow get my current to 2. So to automate the process, I'm going to put a for loop which will run from I equal to 0 to I less than position minus 1, which is 1. So from 0 to 1 means what? I is equal to only 0. So only one time for loop will run. So now cur equal to cut dot next. So here it will end up and for loop will exit. Now what I'm going to do? Cur ka next, update it to cur ka next next. Got it? So this will be gone totally because it's out of the link. So Karka next will be directly pointing it to Karka next next. So see, you know, right? Everyone, first right side, it will be taken Karka next next and saved, and then left will be updated. Got it? Everyone? Yeah, we can take Harsh. It totally depends on us. See, this will be a little bit more complicated and much more. See, the thing is, we will arrays or anything will consider in 0 index only. Unless they give it specifically, unless they give it as 1 index, we'll always consider 0 index. So I took it like this. So is this delete function clear? That's it. We can do a problem now. If it's clear, type clear. If it's not clear, won't work on complex addresses. Complex addresses means what? Complex addresses means what, Swapnil? What do you mean? Clear, clear. I mean, not 0, 1. Are it will work for anything, na? What do you mean 0, 1? What do you mean? Complex addresses. See, addresses we never consider. I mean, where exactly it's being in memory, we won't care about that at all. So it'll work for everything, no? Subtle, like a position means address, right? Position. Okay, are you talking about this delete code? This position? Yeah, a position means not address. Address means something where my variable is storing that where exactly in memory. That is address. And the position is there, right? Why? I mean, on what position it won't work? Any position it will work, right? If at all it's valid position. Yeah. Cool, then shall we do a problem? Let's, is position equals to index? Yeah, exactly. Position means index. let's do a problem. So yeah, can you guys see my screen? No, Rajat, it's total like linked list won't have indexing and all. Like it can have, but the thing is now I said na collections, there is something like collections framework. In that we can make in linked list also array that, but that comes after some lectures. So we'll decide there. So for now, I wrote this. See, positions means zero indexed position. So generally speaking, normal linked list won't have any indexing. It has only links. So this is the problem we are going to discuss, guys. So I'll just talk about it and I'll just directly jump into it. You have so many problems to try out in assignments. Please try out problems in assignments, okay? Because it's very difficult to cover each and every problem and all. So I'll just explain it and then let's directly talk about logic and all. Is it cool with everyone? Because there are a lot of things to cover. Shall I directly discuss? Yeah. Also please send the code to Discord afterwards. Yeah, sure. Okay, let's now only I'll send, because this is for single thing. I mean single linked list. Again, we'll go to double linked list. Separate code will be there. So cool. Yeah, okay, cool. So let's come to this problem. What is this problem? This problem is asking us what is the middle of the linked list. We have to return. See, this is how real coding exams will be there, guys. So this is exactly how it will be there. They will ask us to fill a function. So question is, given the head of a singly linked list, return the middle node of the linked list. See, you are just given with one head node. Okay. I mean, head node. See here, what is list node? They are giving it here. Int value will be there and next will be there. And inside the constructor, here it's constructor. We don't need to worry. I'm just showing it how exactly it's working. Inside this constructor, it's just updating the value. And then it's just like, I mean, if at all it's a parameterized constructor, empty constructor, nothing. One parameter like this, two parameters like this. Like both are parameterized, separate two parameterized constructors. Got it? How exactly it's working? See, they wrote in one line, that's why it might be confusing, but if you open it up and see, it will be clear. So the question is, they gave the head of the singly linked list. We have to return the middle node. And now obviously we'll have this confusion. So for 1, 2, 3, what is the middle node, guys? 2, na? And for great. For 1, 2, 3, 4, there are two middle nodes, na? For 1, 2, 3, 4, there are two middle nodes. And what are they saying? If there are two middle nodes, return the second middle. Means what should I return in this 1, 2, 3, 4? 3, na, everyone? So I have to return 3. So let's come back to our logic now. So the thing is, let's see, always try to generalize. Okay. So generalize for each case. Generalize for each case. While solving the problem. Obviously, we have to check the base edge conditions, and then after it, we have to generalize for each case. What is the case? What are the two cases here?
Odd and even.
Exactly. So let's talk about odd. Let's say odd, right? First, let's talk about odd. So let's say there are n nodes. What node should I target on if there are n nodes?
N by 2.
n by 2, right? So exactly n by 2 we have to target. So if at all n is equal to 5, what node should I target on? 2, right? N by 2, which will be equal to 2, right? 2 means 0, 1, 2, 3, 4. 2 is 3. This is what you have to give. So let's do it with one more example for 3 nodes. So now n equal to 3, right? What is n by 2? What is n by 2?
1.
1, right? So 2 should be our answer. That's what we have to return. Is it clear? If at all odd, n is the length of the number of elements elements in our linked list, n by second element will be our middle element. Yes or no?
Yes.
For everyone, is odd case clear? If it's clear, we'll move on to even case.
Yes, clear.
Clear? Great. So let's move on to even case. So if at all it's even, so that means 1, 2, 3, 4. If n equal to 4, now let's see what exactly we need to do. 1, 2, 3, and 4, right? So if n equal to 4, what exactly we have to return? First of all, let's see what we have to return. We have to return 2, right? Yeah. I mean, yeah, index to element 3, right? So let's focus on index, guys. So we have to return index, second index, right? So basically in this example, we are observing that we have to return n by 2 also, for even also n by 2. So let's see few more examples and decide. So let's see 1, 2 ka example, n is 2. So basically what should I return now? Which index should I return?
1.
1, right? So again, this n by 2 is working here. So let's take one more final example. This is 6. Here it's there, right? 0, 1, 2, 3, 4, and 5. So my n is 6, right? What is n by 2? N by 2 is 3, right? And here, this is what I'm returning. So what does it mean? Even if it's n, even if it's even, or even if it's odd, what element should I return?
N by
N by
2.
N by second element, exactly. So I have to return n by second element. So first of all, what is n? What is n?
Number of elements.
So
or-
basically length of linked list, na? Yeah, length of linked list. But how to find length of linked list? They just gave us head list node of head. They just gave us head, right? How to find n?
iterate till last, like traverse till last,
Exactly.
and make a
Excellent.
count variable.
Exactly. So perfect. Let's just do it then. So let's go into code. So the algo is clear enough for everyone. First we'll iterate, we'll find the n, and then after finding n, we'll do whatever we did before. Cool? Cool. Great. So first of all, my count, I'll create a count which for n, which will be 0. Okay. And then I'll be, obviously I should create a temporary variable. Okay, I think it's not visible. Let's little bit. Is it visible for everyone now? Yes. Okay, great. So first of all, this count is for length of linked list. Okay. And now what should I do? I have to create a current temporary variable, right? That will be C. Here, what is the class name, guys? In our previous class node, right? But here it's list node. So what should I do? List node space temporary variable. I'll create it. I'll just initialize with head. So now while my temp is not equal to null, so basically I'm going to last, like traversing it until the total pura linked list. So what should I do here? My count,
plus.
exactly. And then what should I do? Temp equal to
Count.
temp equal to temp dot next, na?
Yes.
Yeah, great. So here I'm finding in this loop, by the help of this loop, I'm finding the length of my linked list. So now what should I do? Again, I'll make, see, temp is right now null. Okay. So again, I'll make temp as, okay, wait, let me remove is equal to here. Okay. So see, temp is right now null, right? Because it came until the end of the linked list. So again, I'll put it to head, and then what should I do? I'll put my count to count dot. So my basically my target. I'll put something like target index. Okay, wait. I'll put target index, which will be equal to count by 2. Even if it's even or odd, even or odd doesn't matter. Because we checked it, right? Without checking, we won't put, see, every time, sometimes even or odd have different answers, but we checked clearly. So we don't need to worry about it. So now what should I do? While my count is greater than 0, what should I do? Temp equal to temp dot next, right? And then what should I do? See, okay, while my target index, okay, while my target index, okay, is greater than 0, okay, I'll put it as count only, then it will be much more clear. Okay, while my count is greater than 0, see, I can put as target index only, but I just don't want to. Now what should I do? Count minus minus, na? So what should I do at last? I just came out. What should I do? What should I do at the end of the function?
Return the temp value.
Exactly. Temp node, list node, right? If at all you want to access the value of it, what will you do? If at all in this question, see, in this question, they asked you to return the middle node. If at all they're asking you to return the middle node ka value, then temp dot not data. We have to check here. Here val na. So not even value or not even data. So it's just val. If at all they're asking us to return value, but here they're asking us to return node only. So temp. So let's just first run it. Let's see any errors are there. Great. Submit. Great. Cool, right? Yeah. Abdul, the thing is, in the function first check what is the name of the value given. It's VAL, but in our code, we wrote data, right? So see, for accessing data, we'll put dot data, but we have to access value, right? So we'll put dot val if at all it's necessary. Got it, Abdul? We won't put dot data here because dot data will give us total error because it doesn't know what is data. It just knows value. Okay. Line 22, please explain. Okay. See, what exactly am I doing here? Sharon, what exactly I'm doing here? I'm just traversing until the last element and then finding the length of the linked list, right? After finding the length of the linked list, if at all it's n, I'm just making my count equal to count by 2. So now what should I do? Again, I'm traversing from starting until I hit that, until and unless I hit my n by second element, I'll just return my middle element, right? So let's take one example. So let's take example like 1, 2, 3, 4. Okay. So now my count is 4. Okay. My actual n is 4. But here I'm making my count again count by 2, right? So my count is now 2, right? Sharon.
Yes, sir. Yes, sir.
So here this is temp. Temp is pointing to head, right? So is my count greater than 0 now? Right now?
Yes, yes.
Yeah. So I'll just update the temp to next and then decrement my count. So count is 1 now. Okay. Again, it's greater than 0.
Sir, in 17th line.
Sorry?
In 17th line, temp is equal to already initials name.
Sorry? Yeah. Sorry. Got it. I didn't get it. In
17th line, temp is already initialized with.
Yeah. In 19th line, no?
Sir, in 17th line.
In 17th line, I'm updating. This is for finding length, bro. This is the first iteration.
Okay.
This is for finding length. But this loop is there, na? It's for going to middle.
Okay, okay, yeah, I got it. Got it. Okay.
Cool. Everyone, is this logic clear? Okay, it is giving all data from middle, but we are returning only temp now. You should give only middle value. But the thing is, in linked list, they asked us to return the node, and just we have to return the node. You don't want, see how this exact load will look like. I'll show. 1 2 3 4 is there. I have to return 3, right? And how exactly I have to return this? When I return this, it won't give 3 4 5 6 like that. Generally it will be like 3 and then 4 ka address will be there here. That's it. And if at all you want to go to one more thing, you have to go to the 4 ka address like that. So this is the node we have to return. Return this. Got it, Sai Vivek? You are, see, it's totally upon them. If at all they're asking us to return the value, then we will return dot value here and just value. But they're asking us to return middle node, na? So we have to just return the node itself. Temp is created with node, na? List node temp as the data. So that's why I'm going to return the temp. Cool. Is it clear for everyone? This logic and this algo. If it's clear, type clear. If it's not clear, please ask out.
Hello, Sundar.
Yeah.
Like last element will be null, no? So the count will be less than 1. Like, see, sir. Hello.
Yeah, count is initially 0.
Okay.
And then see, we'll say, and then if at all length is 5, count will be becoming 5, right? See, last element is not null. Last element is 5. And if at all you are going after 5, it will be null.
Okay.
Then it will be coming out of loop.
Okay.
Yeah. See, I am not putting temp dot next is null. Is not equal to null. I'm putting temp is only not equal to null.
Okay, got it.
Yeah, got it. So shall we move on, guys? See, one more time I'm saying there is one more very efficient way to solve this problem. Here, what is the time complexity? I mean, considering n is length of my linked list, what is the time complexity here? Big O of n, right? But the thing is, it is passing 2 times. So it's actually big O of 2n, but still we'll call it as big O of n. But in linked list, see this, if at all this question is given in your online assessment, this code will run happily. But in interview, you know what they'll ask? They'll say like, you are traversing 2 times, na? Don't do that. It's n. It's 2 times traversing to pura. So what will they say is, do it in 1 traversal. So it will become so difficult. Okay, it will become difficult. Like we can't do it, but there is one technique which we'll learn tomorrow. Before going that, I want to teach doubly linked list. So guys, keep this in mind. This question will come back tomorrow or day after tomorrow. Like 99% will come to it tomorrow. To solve in only 1 traversal. Exactly, Jay Patel, you are right. 2 pointer, but the pointers are not, they won't be from first and last. It will be for linked list. 2 pointer technique is kind of complicated. So we'll talk in separate session. Cool, guys. We'll come to this question again and solve it in using 1 traversal again. We'll come back to it tomorrow. So great. So in line 22, what's happening with temp? I didn't get it. Line 22. Bro, we are just moving forward, na? We are just going forward. See here in the first loop, what are we doing? We are finding the length of the linked list. After finding the length of the linked list, I made my length is equal to length by 2, because how did I make n equal to n by 2? Every time n equal to n by second element will be my final element. So now my count is, you know what? I'll just put n. Here my n is count by 2. So until and unless my n is greater than 0, every time I'll do n minus minus. Every time I'll do n minus minus until and unless my n is greater than 0. The moment my n is equal to 0, I should just come out. I should just wait, let me just update this. I should just come out, right? Got the point? The moment my n is equal to 0, the moment I should go until and unless my n is not equal to 0. But the moment my n equal to 0, I should just come out and return it. So wherever I am, that is my n by second element. Got it, Tejas? So we are going from mid to 0. No. We are going from 0 to n by second element. Taking input from user, inserting in linked list. Yeah, we'll do that, Nehal. We can do that. Like, see, you know how to take input. We already wrote functions, right? I think you can try it out. We already wrote functions, right? I already taught you how to work with classes. Like, if at all there is any problem, we'll discuss this tomorrow only. So if at all anyone wants to take input from user and try it out, simply like first put a scanner here, take input and store it in some array or anything, and then put loop. And then what will you do? And then put loop, and then use, first create linked list object, and then use the methods using LL linked list ka object. So how will you do? If at all object is something like if you tell you clearly, so LL dot insert at beginning, like that. Got it? Nehal, got it, right? This is how we do. Someone asked, some other person also asked. So great. So let's go to doubly linked list. We'll complete off doubly linked list first. Singly linked list clear. This problem is clear, right? I don't need to see again. We'll come tomorrow to solve it much more efficiently. So for now, this is what we are going to. We are going to stop it here. See, this is. It's still showing as 100, but it's fine. Memory is little bit less. No, let's see with tomorrow's method and see. Just keep this thing and then we'll see tomorrow's thing. Cool. So let's go here, and now let's go back to our PowerPoint here. What is it? Are they just unmute, na? Once unmute and talk. Can you unmute? Bro, you know what? I'm putting this code. You can try. I already did 3-4 times dry run. So once take this second input and first input they gave, and then slowly each update each variable slowly and follow the loops, and then you yourself do. See, first of all, what is the logic? I have to return my n by second element node. That's it, right? Here I'm finding n in this loop, and after finding n, I am again coming from head. Head means what? Again 0th position to n by second position. After coming to n by second position, I'm returning temp. This is what's the point. Everyone got, bro. So does any other person have this problem? If at all you have, no one is there, I guess. But they just, if you can unmute, I can explain it right away. Or do you want to take time and figure it out your own?
So after coming at n by 2, it would print the list from that n by 2 to the.
See, first of all, 90 until 18th line, is it clear? This count means n, bro.
Yeah.
This is until 19th element. 18th line. Are you cool?
Yes.
Right. What am I doing in 19th? I am again re-updating. See, right now your temp is null. That's why loop is broken, right? So again, I'm updating temp with head, right? Is the 19th line clear?
So here head
Okay,
is
I understood. 19th line, you have problem. Wait. 1, 2, 3, 4. Okay. 4 elements are there. What is n right now? N is 4, right? I mean, count. Count
Yes.
is 4, right? Okay.
Yeah.
So now what I'm going to do is, after coming to 19th line, see right now, because of this loop, my temp is somewhere out, right? It was going from here, temp, and then here, and then here, and then here, and then it came out, right? Temp. So what should I do? I'll again re-update temp to head. So what will I do? I'll again re-update temp to head. Temp is outside the total linked list only. See, if at all you don't want to use temp, put cur or put anything, whatever you want. I'm going to put one more pointer called temp to the head, right? So my my count is 4. What did we talk? We have to return n by second from 0, right? So what does it mean? In my linked list from 0, if at all I'm giving index like 0, 1, 2, 3, I have to return count by 2. What is count by 2? My n is 2 now, my target. So I have to return the second element, second index ka linked list. So what I'm going to do? I'm going to, my n is right now 2, right? Is my n equal to 0?
No.
No, right? So what am I doing? I'm moving forward. Temp equal to temp dot next, right? And what am I doing? N minus minus means that will make my n 1. Now tell me, is my n equal to is my n equal to 0?
No.
Will it run again loop?
Oh, yes.
Yeah. So I'm updating temp equal to temp dot next. And then what am I doing inside after that? N equal to 0 because n minus minus, right? Now will my loop run? Will my loop run?
No.
Why?
It will come outside. No?
Yeah. So after it's coming outside, I'm going to return temp. What is temp pointing to? 3. It will return this node. This will be returned. Got it? This is what we have to return, na?
Yeah, but then why there is a 3, 4, 5 in output?
Don't worry about this output expected, na? This linked list will be like that. You got this, right? You got whatever I said, right? It was
Yeah.
like this because linked list will be like the moment I am returning 3, whatever elements are there after it, it's linked list now. So even if I'm returning 3, it will return everything. So you don't worry about the return and all. You don't worry about the output expected like that. Generally, it will be like node. This is what they mean. So don't worry about this. Is the question clear? Is the logic and the code what we have written is clear?
So we are doing n minus minus. So but we are starting from 0. Then
we are not starting from 0. We are starting from count by 2, na?
2.
We are starting from n by 2. So we are starting from n by second. Count by 2 position, right? And then we are coming. See, variable we are decreasing, but we are starting from head only.
Okay.
Okay, bro, you have to spend time. Like you have to spend more time, a lot, to get better in all of these things. Okay.
Okay, so it's just like that factorial problem where while n is greater than 0, we multiply n into
Why
1.
are you going to recursion?
No, like
No, but the point is, yeah, I mean, that's the logic. That's how it's working. Like that only, correct. Cool. Shall I move on?
Yeah.
Pakka, right? You want to spend, or after I kept it in chat box, right? You take it and after class you, like if at all you want more explanation, ping me, okay? In Discord. Cool. Great, guys. So let's move on to doubly linked list. So what exactly is doubly linked list? See, doubly linked list, we are not going to pura code it up because we will rarely use it. The thing is, first of all, let me say doubly linked list. See, you guys understood how we implemented normal singly linked list, right? Doubly linked. Okay, what is singly linked list look like? How many? Okay, you tell me, guys. How many variables are there in singly linked list? Two, na? What are they? Node and data. Array next and data, na? Jay? Yeah, we have data and next. So, but in doubly linked list, we have three things. We are saving the data and next as well as the previous ka address. That is it. And whatever we did with singly linked list, that is it. We are going to do it on doubly linked list, but it's so much more better. So much more better than singly linked list, but more memory because we are saving one more previous address. I mean, got it? Because here we are having previous and next also, right? So got the point. Here we can go back and front. Where did you see in real life example something like this? Tell me. In real life, where exactly did you see something like this? Exactly, Prithviraj. Great. It's browser, right? It's nothing but browser, right? If at all you're going into browser and opening something, and then I'm opening GDB. See, it is, I can go further or go backward, something like, okay, I should not open this. Okay, after opening this, I'll be like, okay, I can go back, right? And I'm going back. I have two options, either going back or going forward. It is the application of doubly linked list. Huh? Got it? Why is it like this? We have both previous and next. Here we have both previous and next. Yeah, browser, yeah, Chrome, yeah, something like that. So got the point, right? Doubly linked list. Here we will have previous and next in doubly linked list. So here again, same thing. But here, before even going that, we will talk about something, how to, like, the classes will be there now before even going to insertion and deletion and all, accessing and all. Here the classes will be there. Now how exactly class will be there? Class, which will be node. Here inside it, we have three things. One is int data, node, previous, and then node next. And then my parameterized constructor will take integer d, and then it will be making it data equal to d. See, I don't need to make previous and next as null initialize because it's already null. So even I can make it like this. See, I can put previous equal to null and then next equal to null. I can do that also. It totally depends on us. Cool. Understood how exactly node will be there on doubly linked list. This is doubly linked list. But in singly linked list, see, doubly linked list minus previous is nothing but singly linked list. Got it? Got it? The difference between doubly and singly? Everyone? Again, same thing, guys. If you got it, nice. So again, same thing. See, this is how we represent. So that's clear, right? So again, same thing here, but keep it in mind. We have previous and next. It is not just singly linked list. It's better than singly linked list because we have two things, previous as well as next. So the point is here, again, same thing. Insertion at beginning. So insertion at end, insertion after a node, like middle, basically. Like middle means in between, you can say in between. Similarly, delete first node, again delete. Okay, we came to end. Delete first node, and then again delete last node, and then delete specific node. So these are the things which are to be coded. So shall we start, or will you take time and get it? So previous and next, don't store address here. Okay. See, the thing is, we will understand, Tejas, the thing is, we will understand that previous will store the whole, see, previous is there, right? It is, means, what do I mean by storing? I mean storing means just connecting it. That is where it connects. My previous is connecting to my, okay, I'll just show how it connects, guys. It is very important. I am not able to, yeah. Okay, let me show how it connects. So already pen is open, right? So look here. So 3 things. 1, my previous of the first node is null, right? And my head is pointing to this. And now my next of my first node is pointing to the previous of my next node, right? And this is 2. And my next of my this node, it will be pointing to my previous of the next node. And this next will be pointing to null. Is this clear? This is the representation. But what is the simple representation of single node? 1 directly pointing to 2, directly pointing to 3. Only next is there, but here previous as well as next is there. Got it? They just now got it. It's just pointing. Don't visualize like it's storing just like that. Like it's simply like pointing. That's what you can think like. Okay. So guys, do you feel it's more for today? Anyone? Like I want to go on. Yes, everyone are saying yes. Harsh, no. Okay. See, please sincerely tell me, did you guys understand this notation? If you guys understood this notation, see, I want each one of you, every one of you to write the logic of these 6 functions. Inserting at beginning, inserting at end, inserting after a node, deleting first node, deleting last node, deleting a specific node. We are going to do this in the first 20 to 30 minutes in next class. Or shall I do it now? I want to do it now, but see, I don't want to make it total bad. Shall I do it now, guys? Shall we? I mean, we are only going to talk logic anyways today for sure. Okay, great. We'll do it now only. In singly linked list, there is no null. Okay, Rajat is asking, in singly linked list, there is no null for first element, but doubly linked list have null for first element. The thing is, it have null, but the point is, it's not next, it's previous. We have previous, right? That will be like that. Yeah, I mean, Rajat, you are right, but it looks like that. You know what? I'll just write. So inserting at beginning. So what should I do for inserting at beginning? First of all, obviously, The obvious thing is, yeah, previous of correct. Previous of last element is connected, previous of second element is connected to first element ka next. Wait a minute. Previous of second element is connected to first element ka next. We'll just move on. We'll just see now how exactly it's looking and all. Then we will see. See, this head is there now. This head is pointing to this part. Previous. So basically, I mean, it's not exactly previous, it's just node. Head is pointing to this node. Okay. And then it works like this. So let's see how exactly inserting will be there. So obviously create node, right? After creating, what should we do, guys? Create new node. Okay. I'll call it new node. What should we do? Put in chat. Great, great. So what should I do here? Set previous and next pointers. Like, see, first of all, my new node dot next will be head. Will be the first, right? You won't say exactly. See, new node dot next will be why head dot previous, bro. New node dot next will be pointing to head, right? It's not head dot previous, it's directly head, na? Like, yeah, cool. And now after it, what will we do? New node dot next you did, new node dot previous, it's already null. So we'll just leave it like that. And then we have to make new node at s. New dot will be equal, sorry, head equal to new node, right? Head equal to new node, right? Got it, everyone? If at all I want to insert at the beginning. Yeah, exactly. Great. Great. So if at all I have to insert at the end, what should I do for inserting at the end? Obviously, as usual, create new node. After creating new node, what should I do? After creating new node, what should I do? Yeah, obviously first traverse. Great. After traversing, so let's just take an example, something like 1, 2. I have to put 3 at the end. Okay. This is looking like this. Null. This is okay. This is null. This is the head, and this is pointing towards null. I'm coming to the last but one element, and then what should I do? And then we have to just simply make my, see, this is my curve. So first of all, after traversing, my curve will be curve dot next will be pointing to my new node, right? This will be my curve. So my final, my last node ka next will be pointing to my new node, right? And then what's the one more connection I should do? What's the one more connection I should do, guys? No, Arey, why Srinidhi, why head will change? We are inserting at the end, na? Exactly. No. Harsh is right. We have to get new node ka previous to last node. Great, everyone. Is it clear? Last means I mean curve. After traversing, the last element is I mean curve. Got it, everyone? And then if at all I want to insert in between. See, guys, I think you got the hang of it. Did everyone got the hang of these problems, these two problems? In previous example, we didn't update priv. Are we updated priv na? Here, we don't need to update priv na? Aishwarya, it's already it's already initialized with null only, na? I'm inserting at the beginning. My new node will be my new node will be the first head. So here head is already previous. It will be pointing to null. I mean, why do I need to update it? No need to update previous of new node, na? Got it? I'm inserting at the beginning means my new node itself is head. I don't need to change anything to it. It's just null. So it's already, yeah, okay, cool. We should try first other random methods for TLL, then yeah, bro, that's what. The thing is, some people are asking to do now. If at all anyone wants to try on their own, you can leave. It's fine. It's up to you. See, anyways, like the thing is, it's not just correct for me also to teach each and everything. You have to try. Like I told these things, right? It's exactly like, do you guys feel like it's exactly like singly linked list? Tejas, I think you should spend more time because everyone are being active. So you should spend after completing of this class, please spend more time because you did not understand that problem. Now, once I'll send the link of that problem. Once you focus and then before tomorrow's class, please get better, or else send a message in Discord. We'll talk. Okay, great. Guys, did you understand this insert at beginning and insert at end? See, that simple thing. A singly linked list we already did, na? Singly linked list plus updating previous is simply doubly linked list. That's it. Nothing more than that. Here, doubly linked list, we can even the general application, the general benefit is in doubly linked list, we can do undo and then redo, something like that. Got it? We can go front and back, right? So that's the benefit of a doubly linked list. That's it, guys. I don't want to take much more things. Like I suggest you guys to write out the logic for inserting at the middle. I mean, inserting a node, delete the first node, delete the last node, delete specific node. These 4 things. Like these are exactly same as those things, guys. I don't want to take much more time. What about the preview of second node after inserting a new node at head? Okay, good question. Wait, let me see. What about the previous node? See, inserting new node, previous of second node. I'm updating it, na? I have to update previous of second node, which is initially my first node, to next of my new node. Got it, Harsh? See, you should just write diagram. My previous of that node will be pointing to my next of my first node. Got it? Yeah, I have to try. Okay, that's it, guys, for tonight. Please write those functions. I mean, write those logics and try. So, did you guys feel today's tough? Yeah, like definitely tougher than yesterday. Little bit. Good. Nice. See, you have to work. I said you now. See, for trying out problems, you have tons of problems in your assignments and everything. Yeah, doubly linked list is actually easy. Like more applications will be there. See, it's simple. Just draw the diagram. Okay. Let me just once share screen and finally. Okay. Anyways, tomorrow I'll come, bro. Tomorrow I'll come to this doubly linked list only. So doubly linked list, if at all, if I'm the middle node, my previous node will be connected to, see, my previous pointer will be connected to my previous node next, and my next pointer will be connected to what? My previous of, you know what, you draw the diagram. I don't want to say it like this. Yeah, next of pref, correct. But yeah, draw the diagram. If it's not clear, we'll talk tomorrow. It's fine. Cool then. Shall we go? Good night then, everyone. Bye bye. If we'll know the basics of linked list, will it be enough? No. That's why doubt session is and all is happening. So tomorrow we'll learn one technique. I said you not how to do it in one traversal. That is the one most important technique in linked list. If at all we do that technique, we can do good number of problems in linked list. And Nehal, the thing is, the point is, you have to know the basics and implementation. Implementation is very important. In interview, they'll be like, what is the benefit? See, one of my friends interview at AB InBev, nearly 22 package, I guess, 22 lakhs. They just asked, what's your favorite data structure? Obviously, we all discussed, we had a plan. If at all any interviewer asks, what's your favorite data structure? We will say linked list only, because they can't make it much more tough on linked list. They really can't make it tough, because if at all you know one technique and implementation and all the why linked list and all that stuff, basically you don't need to learn anything. You don't need to create anything new. Everything are existing. So that's what that interviewer asked my friend. He asked like, what's your favorite data structure? He obviously said linked list, as we discussed. So that's it. Pura linked list asked for implementation and asked 2-3 questions. Katam, that's it. Whatever is existing, it will be there. So please focus well on assignment problems. Most difficult data structure is not at all linked list. It will be graph. Graph will be most difficult data structure. Like not just for me, for anyone, because that's the advanced data. That's like the father of all data structures, because from graph only you can get everything, tree, linked list, anything. So heap, anything like that. So cool, guys, let's meet tomorrow. I want you guys to please try out this homework. So good night, bye bye, take care. Good night, bye bye.